The Smithsonian Faculty Fellowship Program represents a rewarding academic professional development opportunity for faculty at Montgomery College. The fellowships are a product of a unique collaboration between Montgomery College and the Smithsonian Center for Learning and Digital Access. It's the first of its kind between the Smithsonian Institution and a community college.
Virginia L. Miller received her BS degree in chemistry from Rider University, a PhD from Princeton University, and was awarded a National Research Council postdoctoral fellowship at the U.S. Army Research Laboratory. Since joining Montgomery College in 2008, she has been involved in numerous outreach activities designed to encourage students, especially underrepresented groups, to pursue a career in STEM. She has also focused on integrating innovative teaching methods into her courses to improve student success and engagement. She is a recipient of the Montgomery College Outstanding Faculty Service Award and the Award of Excellence from the National Institute for Staff and Organizational Development.
Good afternoon. I'm excited to talk to you today about how I incorporated this theme of exploring chemical innovations in American spaceflight into my Principles of Chemistry 1 course. So first, I want to give you a little bit of background about this course. Principles of Chemistry 1 is our freshman general chemistry course that all of the STEM majors have to take. There are 3 main components: a lecture, discussion, and laboratory session. It is a very content-heavy course, so we cover a lot of different chemical concepts, but we also try to help students develop their critical thinking, problem-solving, and teamwork skills as well. Now, all of our STEM students have to take this course. So I'm always looking for new ways to excite and inspire my students, as well as to enhance the learning experience. So my inspiration for this project was the book, and of course the corresponding movie, The Martian. So there's a lot of fascination with the idea of going to Mars. So I wanted to harness that excitement and that energy and bring it into the classroom. So I decided to redesign my entire course around this theme of chemical innovations in spaceflight, so that my students could explore different spaceflight technologies from the past, present, and future as we journey to Mars. So in redesigning the course, the first thing I had to do was to look at all of the different topics that we cover and find the connection to some aspect of spaceflight technologies, whether that was the material used in spacesuits or spacecraft, or the chemical reactions involved in rocket fuels. Now, this was a very educational experience for me because I am not a rocket scientist. So I learned a lot in the process, but I had a lot of fun as well. And my goal was that students would have fun also, because they're still learning these basic principles of chemistry, but they're doing so within the context of different spaceflight technologies. So I thought that would be a fun and engaging experience for them. So the first exposure to the theme my students had was in the classroom. So I teach this course using a flipped classroom approach, which involves a lot of group activities, and these group activities are usually focused around several different worksheets. And each of these worksheets contains some problem sets related to a particular topic in chemistry. So in keeping with the redesigned course, I redesigned all of my worksheets, so that now all of the problems or the reactions or the things we talk about has to do with some aspect of spaceflight technology. And wherever possible, I tried to incorporate a little bit of history, a little bit of background about that technology, explain where it was used, what was so innovative about it, and even include, say, a picture of an object from one of the Smithsonian museums. So on this particular worksheet, which deals with gas laws and chemical reactions, I talked about some of the chemical reactions that were used to remove carbon dioxide from inside a spacecraft, so astronauts could continue to breathe safely and effectively. And I wanted the students to make the connection between the different chemical concepts we were talking about, an application, as well as maybe a little bit of history, and an object at the museum as well. So really fully engage them in this theme, and it also gave us a chance to talk about these different technologies in class as we were going through the different problems on the worksheets. But I also wanted my students to engage with this theme outside of the classroom. So I used the Smithsonian Digital Learning Lab to create several different homework assignments, which I called activities because nobody likes to use the word homework. And so the Smithsonian Learning Lab is a free online educational platform that has over 1 million resources from the Smithsonian Digital Collection. So very useful and very applicable to many different disciplines. And so I used this to create 5 different activities, where each activity was focused on a particular aspect of spaceflight technology and the corresponding chemistry. So this is my assignment that I created on rocket chemistry. And as you can see, it's a collection, almost like a little mini museum collection of websites, of articles, of short videos, as well as images of objects from the Smithsonian collection. And students would go through and interact with these different resources. They would watch the movies, they would read the articles, they would go through the text, and they would learn about the chemistry of the different rockets. So they would explore the Saturn V rocket, the rockets involved in launching the space shuttle, and I also included some future technologies, the idea of an ion engine, which was used in The Martian, and it's still used by NASA, so NASA does use it, and the idea of plasma rockets. Can they get us to Mars faster? And at the end of every activity, you see there's a PDF document there, and that contained a list of questions related to the information presented in this collection. So students would print out that document, answer the questions based on what they learned, and then turned it in for a graded assignment. And the students really seemed to enjoy these activities. They all completed it. They talked a lot about it in class. They seemed to really enjoy diving deeper into these concepts and making those deep connections. And I wanted to share a quote from a student who said he enjoyed doing these learning lab activities because it helped him visualize the chemistry a little bit better. So students engaged with this theme outside of the classroom. They got to explore different technologies. We talked about different technologies inside the classroom, and all of that was leading up to our capstone event, which of course was the visit to Smithsonian museums. And we were fortunate to visit 2 museums. The first one was the Udvar-Hazy Center in Dulles, Virginia, which is the companion facility to the Air and Space Museum. And we spent a whole day at the museum. We actually left campus around 9:30 in the morning and didn't return until about 5 o'clock in the evening. And I was able to do this because of the way my course is scheduled. Every Tuesday, I would meet with my students in the morning for lecture and discussion. And then a few hours later, I would meet them in the afternoon for a 3-hour lab. So basically, students did chemistry all day on Tuesday. They didn't have any conflicts with other classes or work commitments. So I used one Tuesday, that big block of time. We went down to the museum and spent the whole day there. This is a class photo in front of the space shuttle. Now, while we were at the museums, we were given a guided tour of the spacesuit collection by Dr. Kathleen Lewis, who is pictured in the photograph in the upper left. She's the curator of the International Space Programs and Spacesuit Collection at the Smithsonian. So she talked about some of the early pressure suits, some of the prototypes that NASA developed for going into space, as well as the Apollo-era spacesuits. And if you look in the upper right-hand corner in that picture, you see 2 students holding what looks to be a sheet of paper. It's not paper. It's actually fabric. It's the fabric that they used in the construction of spacesuits. So Dr. Lewis brought in some samples that the students could actually touch and feel, and they could flip through this packet of fabric to see all the different layers that went into making a spacesuit. And she also brought in some samples from the Russian spacesuits as well, so students could kind of compare and contrast. So that was a really fun experience for everyone. And I want to share a few quotes that students had about this experience. They did write a reflection about the visit, but since we're talking about what they did, I want to include a few quotes there. I love the first quote because it shows how the student was taking home what she learned and sharing it with her son. And then she later told me that she was planning on taking her son to the museum to share that with him as well. So I thought that was really sweet. And the second quote really highlights how impactful it was for the students to actually be able to feel and see this fabric in person, as opposed to just reading about it or seeing a picture online. Now that wasn't all. While we were down there, we also had a guided tour of the Space Shuttle Discovery. And this was given by Dr. Valerie Neal. She's pictured in the upper right-hand corner photo there. She's the department chair and curator of the Space Shuttle. And she gave us a fascinating presentation of the chemistry of the shuttle, from the thermal tiles that protect it from the heats of reentry, to the chemistry involved in launching the shuttle, and then of course the chemistry in the main engines of the shuttle. Now, she also brought in samples for the students to feel as well. So in the lower right-hand corner picture, the student looks like he's holding a block on his back block. What is that? It's actually one of the thermal tiles from the shuttle. So she brought in several different sizes and shapes that students could handle, and we had talked a lot about this in class. So we had talked about the purpose of the thermal tiles. They had did a learning lab activity looking at the thermal tiles as well, but now they actually got to hold it. And they said, oh, okay, yeah, we know it's lightweight, but then when you hold it and you realize, wow, it doesn't weigh anything. It's really lightweight. That was really powerful for the students to see how something that is pretty much almost air is so critical to protecting the shuttle. And so many students commented on how that was a really amazing experience for them. And for many students, this was their first time at the Udvar-Hazy Center. It was their first time actually seeing the space shuttle and learning about the chemistry behind it. So very, very powerful experience. Now, about a week after we went to the Udvar-Hazy Center, we decided to go down to the National Mall to visit the Air and Space Museum. And we did this outside of the normal class time. We met down there on a Thursday afternoon, and I will tell you that the first week of November, on a Thursday afternoon, there is no one in the museum. It is empty. It was fantastic. This was outside of class, but students found a way down there. We all gathered in front of the lunar module and had a little bit of fun spending a few hours in the museum. And at this museum, we actually did a scavenger hunt. So students were given a worksheet that I had created with various different questions related to different exhibits throughout the museum. And so they had to go and compare and contrast objects or look at a model of something, as the students would look at the model of the Saturn V rocket, answer some questions about these objects and these artifacts. So they had a lot of fun kind of looking for the answers while also looking at the objects. And in the photo in the lower left-hand corner, you see there's a student having his picture taken in front of the Apollo 11 command module. Now this was for another assignment that they had to complete. And while we were visiting the museums, the students had to look for an object that inspired them. And once they found that object, they had to take a picture in front of that object. And then when we returned, they had to write a little essay about what was so inspiring about that object, what was so innovative about it, and where was the connection to chemistry. And they could pick any object from any exhibit. It didn't have to be from one of the space-themed exhibits, although most students did choose that. The Apollo 11 command module was very, very popular, as was the space shuttle, because it spoke to a lot of students. It was very powerful. And I just want to share one quote from a student who was inspired by the Apollo 11 command module, because it made her realize some of the risks that people take as they go into space. And she hadn't thought about that before, so I thought that was a pretty powerful statement. So this kind of leads back to my original goals for the project. Was I able to excite and inspire students? Did I enhance the learning experience for them? And I think the best way to answer those questions is with some quotes from some students, because students say it best. So these are some of my favorite quotes. I think they are very touching and very sweet. And especially the one where the students said that going to the museums as a group made them feel like a scholar, not a student. So that was very, very impactful. And students were inspired by the objects that they saw. The experience helped them make connections to the chemistry they learned in the classroom. So I would consider this proof that yes, the project did inspire and excite and hopefully enhance the learning experience for my students. And I'd like to end my presentation with a great big thank you to all of the wonderful individuals at Montgomery College and the Smithsonian Institution who helped make this fellowship a truly amazing experience for me and for my students. So thank you so much.